So, what we're doing here, we are looking at inverse functions and how to find them. So here's one, f of x equals 1 over 3 minus x plus 2, and then we've got another one, f negative 2 to 5, so that's our domain, and it's a subset of all real numbers. For this thing here, f of x equals x squared minus 2. So what we're going to play around with this one first, and then this one we're going to go through how to do it. So first thing to remember is that what do we know about the domain and range of a function and its inverse? That's right, we swap them over. So what the domain is in the original becomes the range in the inverse, and what's the range in the original becomes the domain in the inverse. So with this thing here, now just let's think about this thing here. We've got f of x equals 1 over 3 minus x plus 2. So I know we're going to have it, we're going to asymptote at 2, at y equals 2. And then we're also going to have an asymptote at 3. Or rather, x equals 3. Because as soon as x equals 3, when it was divided by 0, it doesn't work. Now, I've also got a negative x here, so it's always been reflected in the x-axis, in the y. So we're going to go, so our normal graph will do that. We're not doing that this time, we are doing this. Okay, so that's what we've ended up with there. That's our graph. So now basically we're going to find the inverse. Well, we know that if we're finding the inverse, we have to swap or interchange x and y, and I probably should have written this as y equals 1 over 3 minus x plus 2. So now we're going to swap x and y, so we'll have x equals 1 over 3 minus y plus 2. And then we're going to solve for y. So bring this 2 over to the other side, so x minus 2 equals 1 over 3 minus y. Multiply both sides by 3 minus y. So we'll have x minus 2, 3 minus y equals 1. Now we divide by x minus 2, so 3 minus y equals 1 over x minus 2. And now take away 3 from both sides. Negative y equals 1 over x minus 2 minus 3. Multiply everything by negative 1. Y equals 3 minus 1 over x minus 2. So there we go. So now, based on this, we have a asymptote at 2. So I'll use a different colour for this one. So an asymptote at 2, a vertical at x equals 2. So we've got one here, and we've got one at y equals 3. X is positive, but it's been reflected in the y-axis, so we're going to go this way. I think it'll look like this, but I'm not 100% sure. Anyhow, it's going to do something like that. So that's what we've got there. So if you're asked to state the domain, so the domain of the original is all real numbers apart from 3, and the range is all real numbers apart from 2. Well then, for the inverse, the range is all real, the domain is all real numbers apart from 2, and the range is all real numbers apart from 3. Now, I forgot to do something here. What is it? That's right, so I've got to make this f to the power negative 1. So we should actually have f to the negative 1 of x, put that negative there, equals 3 minus 1 over x minus 2. Okay, let's have a look at this thing here. So for this, we've got negative 2 to 5, and here's our graph. We know that this is going to look something like this. From negative 2, which will be about here, to 5, which will do that. So now, once again, we swap x, and so we let this equal y, so we say y equals, put in our endpoints, one there and one there. Y equals x squared minus 2, swap x and y. So we have x equals y squared minus 2. Over here, I will have x plus 2 equals y squared. So therefore, y equals plus or minus the square root of x plus 2. So I'm going to draw that in another colour. Try orange. Square root of x plus 2, so we're going to go here to negative 2. That's our endpoint, and we're going to go out to that way, and then that way, or not quite so far. We're just going to go down to about there. Now, we have a problem in that if we were to do a vertical line test, so f negative 1 of x equals plus or minus the square root of x plus 2. Now, if we were to do the vertical line test to find it if it's a function, we have it crossing twice, so we can't call it a function. So we may have to restrict the domain first. In which case, for a parabola, we restrict the domain at the turning point. So that tells us we're restricting the domain there at x equals 0. So we're going to restrict the domain there at y at so that the range is restricted from there. And then we can either choose the left half, which will be this part, or the right part, which will be that part there. The other important thing to remember is that the function and the inverse intersect on the line of y equals x. It's because we're swapping our values over. So that's what ends up happening. So let's go through this again. We're finding an inverse. We state the function. We wrote it in the form of y equals, swap over x and y, and then solve for y. And then we state f to the negative 1 of x is that. X and y values swap over, and what was the domain becomes the range, what was the range becomes the domain. If we've got our domain restricted to something, don't take that as being the range of the inverse function, because they state the inverse function, well then you've got to be careful that you don't end up with it crossing the line twice. So you'd have to restrict a domain to then turn your function 1 to 1. To turn your original 1 to 1, so you actually have a function for your inverse, if you need one. But that's your inverses taken care of right there.